Problem 6.18. Determine the smallest moment of inertia, I, required for the beam shown so that its maximum deflection does not exceed the limit of 1 over 360 if the span length of the span length. Use the moment area method. So this is our figure. It is supported by pin and the ruler, and it has a distributive load of 3 K over feet. So the first thing to do is to find the reaction nitong mga support natin. So i-draw na lang natin yung figure natin dito. So we will supported ang ating structure ng pin support and a ruler, and it has a distributive load of 3K per feet. So hanapin natin dito yung smallest moment, also the maximum deflection ng ating structure. So first thing, 'di ba, hanapin natin yung reaction. So, reaction nito has two reactions, vertical and horizontal. So labeling it as A and B. So AY for the vertical and AX for the horizontal, and we all know the ruler has only one reaction, which is vertical, so BY. So para manap ng reaction natin ang AY tsaka BY, so tsaka AX, magte-take tayo ng moment, which is dito muna sa may B. So summation of moment at B is equals 0 and all up and all counterclockwise positive. So mag-take tayo ng moment. Anong first natin, 'di ba? AY. I mean yung length pala nito, hindi ko nalagay. Yan yung length dito, 20 feet. So AY times, and it is rotating clockwise, so negative yung AY natin, and then yung arm length, which is 20, so yung distributive load 3 times and rotate positive, so 3 times 20 times half, so 10 is equals to 0. So AY is equals to 30 60 times 10, 600 divide 20 equals to 30, and it is, sa transpose mo doon, positive, negative, it is ang direction nito upward. And then yung BY natin, para mahanap summation of forces, vertical is equal 0, no, upward forces positive. So AY 30, 'di ba? Positive. BY upward plus 30 minus 60 is equal 0. 60, ito yung concentrated load natin, 3 times 20, so 60 BY is equals to 60 minus 30, 30. So direction nito upward. So nahanap natin yung yung mga reactions. So next is going to find the moment ng moment nito. I mean, first muna natin i-draw yung deflection, di ba? Pag ito yung mayroong distributive load, considering pag limawa ito yung natin, and this is the horizontal line lang. So ang mangyayari sa ating structures is nagiging ganito. So and then the problem here is and we can see that the maximum moment here is located at the midspan, sa gitna ng ating parabolic. So first thing is hahanapin natin yung maximum moment dito. So, solving for moment, para mahanap yung moment, distributive load na lang ang hanap, ang iti-take natin ng moment. So, mangyayari niyan, distributive load na, di ba natin is 30, and then so solving for the maximum moment, it is moment is equal to 1/2 times half ng 20, which is 10, and then yung reaction natin dito sa 30. Kasi ano man ito, palimba paghatiin natin ito dito na area, diba? Ito na area. So, paghatiin natin ito dito, diba? Ito. So, we can create a positive moment. Positive shear is downward, and then positive moment is rotating. One siya. Counter. So, limbawa may 30 tayo dito na reaction, and then may distributive load tayo dito na 1. So, solving for the moment, yung the moment, so 1/2, gitna nito, 1/2 times 30, yung reaction dito, and then, ang half ng ating span. So, 1/2 times 30, so, the answer is 150 feet. And this is our maximum moment. So, we all know that in solving the deflection, the formula is the maximum. So, we label it the maximum. So, 1/EI, and we all know that EI is constant. So, but then, isosolve natin yung inertia dito mamaya. Kasi ito man rin yung hinahanap sa ating problem. And then, times the area of moment times its centroid. Diba? Pag ang moment natin naka ano siya, diba, ito naka parabolic, and then our area of moment, same with the process kanina, which is in formulating the area. Diba, pag naka first degree yung ano natin, yung structure ay yung drawing natin, in solving area magpa plus 1 tayo, solving area. So naka 1/2, diba, itong end natin. So we all know that our end is second degree. So in solving the area magpa plus 1 ito, so magiging 2. So 2 plus 1 magiging 3 na siya. So from here from point A to point B, 'di ba? Ano siya? Kung magso-solve tayo ng area, 1/3 yung distance niya. So we all know that nasa gitna man yung natin, yung maximum moment. So, it is been under sa 2/3 ng ating area of the moment. So, 2/3 times the area ng moment natin, which is 150, times yung span niya, half ng span, which is 10. And then, we all know that the solving for the centroid ng parabolic is 5/8. 5/8. So, 5 times 10, magiging 5 times 10 ito, divided by 8. So, solving for the maximum deflection is equals to 6,250 feet cube over EI. So, this is our maximum moment. So, nahanap na natin yung maximum moment. So, next thing is we're going to find the smallest moment of inertia, which is itong I natin. So, it is said that so that the maximum deflection does not exceed the limit of 1/360 of the span length. So hindi daw siya i-exist sa length times the 360 ng ating structure or ng ating span. So, ganito yung mangyayari. So, solving for the maximum inertia is equals to the length, diba? Length times the 1/360. So, it is same just like this. So, it is equal to, so, naka-fit man yung kuha natin yung length ng ating, so, i-convert natin ito, gagawin natin siyang inches. So, we all know that 1 feet, there are 12 inches. Just like in one ruler. So, 1 foot, meron 12 inches. And then, yung span natin, diba, lang yan, ang span natin is 20 times, para maging ano siya, inches, 12 times 12 times 360. So, it is equal to I is equal to 559 inches to the fourth. So, this is our smallest moment of inertia, and this is our maximum deflection with regards in this kind of structure. Problem 7.0. To determine the smallest cross-sectional area, A, required for the member of truss shown so that the horizontal deflection at joint D does not exist in millimeters. So, used virtual work method. So, in this problem, we're going to find the cross-sectional area. So, we all know that our structures is supported by the ruler and the pin support. So, let's draw it in this paper. So, the first solving that we're going to do is the real system. So, this is our pin support, which has two reaction, which is horizontal and a vertical reaction. So, and our ruler has a reaction of vertical only, and our structure is having a concentrated load vertically of 15 kN and horizontally 100 kN, and in this area 50 kN, and its length here is 4 meters, and this area is 3 meters. So given that our E is a constant and elastic modulus is 70 gigapascal. So the first thing we do is to find the reaction so that madali na natin ang paghanap ng mga forces mamaya. So we're going to find the summation for us to determine sa mga reactions ng ating point A and point B. So we label it D and C. And meron tayong diagonal dito sa A. So we're going to take the summation for us to determine the reaction at point A at point B. So summation of moment is equals to 0, and considering counterclockwise positive. So mag-take tayo ng moment sa point A for us to determine mag-take muna lang tayo ng moment sa may B para mandali na lang yung pagkuha ng mga forces mamaya. So sa point B tayo. So the first forces na i-moment natin is yung A vertical, which is AY times its arm length, which is 3, and then yung 50 natin, and facing rotating clockwise, so it is negative, and then 50 it is rotating positive, I mean counterclockwise, so positive 50 times the 3, and then the 100 Newton, which is rotating clockwise, so negative 100 times the vertical length, which is 4. So we're going to find na ang value ng AY natin, considering that this 50 here, itong 50 dito, tsaka ang horizontal forces na nag-react dito sa A is 0. Walang moment na mangyayari dito ng mga part. So solving for AY is equal to 83.33 kilonewton, and it is facing downward. So itatranspose mo lang yan, itatranspose. So ayun na, divide natin sa 3. So ganito yung mangyayari. So 100 times 4 minus 50 times 3 divided by 3. So para makuha itong AY natin. So nakuha na natin yung value ng ating AY, and then para madali lang yung pagkuha ng ating B na ngayon. So we're going to find the summation of forces vertical. Kasi vertical man yung hinahanap na forces natin, which is yung BY. So summation of forces vertical is equals to 0, and all of forces are positive. So positive downward divide tong AY natin, which is negative 83.33 plus BY, considering na ang direction ng ating BY is upward. So BY minus 50 is equals to 0. So BY is equal to, transpose lahat, so adding 183.33 kilonewton, and then upward. So correct yung ating direction ng forces dito sa my vertical. So and then we're going to find the forces naman nag-act horizontally. So summation of forces horizontal is equals to 0, and all to the right direction are positive. So AX is positive, which is facing to the right, and then 100, which is positive pa rin. And meron pa ba? Diba wala na. So equals 0. So AX is equals to 100 kn facing to the left para mag-equilibrium tayo. So nakuha na natin yung mga forces na nag-act dito sa AY, AX, and BY natin. So in this time, we're going to solve na ng mga forces natin sa every segment. So we are going to use the joint method. So first, punta tayo sa joint C. So at joint C, so dito na area, so dalawang forces dito, di ba? So we're going to consider the tension muna tayo ng mga direction. So ganito yung mangyayari sa ating figure sa joint C, which is may reaction dito ng 100 and 50 dito. 50. So we're going to find this structure, this reaction here, di ba, konektado ito sa D. So this is the joint or the point of reaction of CD, this area, and C, or alphabetically pagsunod na to, AC na lang tayo, AC, di ba, pointing A naman itong C. So now we're going to inuna natin yung joint C kasi mas madali ito hanapan ng mga reactions rather than others, kasi tatlo yung mga reactions na hihahanapin pa natin sa kanila, but then dito sa C is dalawa lang. So find the summation of summation of forces na lang tayo para mahanap natin ng AC and CD. So, summation of forces, first, vertical muna tayo. Summation of forces vertical is equal to 0 and all upward forces are positive. So, AC is facing downward. So, negative AC minus 50 is equals to 0. So, AC is equals to negative 50 kN and it is facing downward, which is negative. Diba? So, next, forces na naman tayo vertical. I mean, horizontal na naman tayo. Summation of forces horizontal is equal to 0 and all to the right forces are positive. So, CD is facing to the right. So, CD, positive CD plus 100 is equals to 0 and CD is equals to 100 and it is facing to the left. So, nahanap na natin ang forces na na-act sa CD and AC, which is 50 and 100. And then, punta na naman tayo sa may mga madadali lang. So, point B na naman tayo. Point B. So, at joint B. So, we all know that this is its drawing. So, and this part here is connected to B. So, alphabetical ang pagpasunod natin. Pag-arrange rather. So, BD and then A, B. So, diba tension lahat? Tension. And then, meron tayong forces na nag-act dito which is 183.33 kilonewton. So, hindi ko na ilalagay. So, and then, same thing to do. Summation of forces. So, first, vertical muna tayo. All upward forces, positive. So, anong mga forces na vertically? Diba, BD at saka ito yung concentrated load na natin. O reaction na natin. So, BD upward, BD positive. Plus, 183.33 is equals to 0. So, BD is equals to 183.33. And negative man ito kung transpose natin. So, mag-change sign negative. So, it is downward. So, yun na. Diba? Wala namang nag-act dito sa AB natin. Walang forces. So, we considered mag-summation tayo. I mean, directly na natin sa sagot na lalagay dito na AB is equals to 0. Diba? Wala namang reaction na nag-act dito sa AB, which is ang lang siya, yung kanyang lang. So, we can conclude that AB is 0. So, our next part here, magte-take na naman tayo ng moment sa ating na lang din pa natin nahanap, 'di ba? AB, AC nakita na ba natin? AC, meron tayong AC which is 30, ang CD, ang AB and BD. So we're going to find the AD na lang. AD. So considering this area sa point A tayo. Dito na area, point A. At joint. So, we can see that the drawing is just like this. I mean, may diagonal dito. This diagonal is connected to D, which is AD. So, this is thing ito yung last na hinanap natin. So, we all know that the point at AC rather, AC, diba? Anong force na nag-act sa AC kanina? AC is 30. So, 30 yung AC natin, diba? So, lagay lang natin AC. And this is AB. And, meron tayong forces dito. I mean, the reaction which is ilan ito? 83 downward na itong natin ng direction downward. So, hindi pa ito upward. So, downward na kasi nakuha na natin downward. So, 83.33 and dito, meron tayong 100. Dito nahanap natin kanina. And this is to the right. To the left rather. To the left. 100. So, Para mahanap tong AD natin, we're going to find the forces vertically. So, lalagyan natin dito ng condition, which is, andito is 3 ang run and 4 ang rise natin. So, summation of forces tayo. Summation of forces vertically is equals to 0. Ano, upward forces of positive. So, downward, mga forces na nag-act vertically. First, 83, which is negative 83.833. Next is AC, which is, ilan yung AC natin? 50, so negative. And then, ano pa? Yung component. Kung component, you're going to use component, di ba? AD, which is upward, so positive. So, considering upward, di ba? Ano tayo, tension. So, upward plus AD. Ano yung kuan niya? So, 4D. So, ano niya? Yung, ano dito? Yung sine. Which is sine, theta niya. So, diba, para mas laban sine theta is 4 and then the hypotenuse. So, solving the, so we're going to times the AD here at 4 times the square root of 3 squared plus 4 squared. So, that's all for the, forces of vertical, so it's equal 0. So, applying this, we're going to solve this as, so negative 83, combine na natin. So, naging ano na siya, transpose lahat, AD, 4, we all know that this is square root ng raised to 2 ng 3, 9 plus 16, 25, so square root ng 25, diba 5? Is equals to, transpose lahat, 100, 133 rather, 133 3.33, then AD is equals to 166.67 kN, or di ba positive, so it is upward forces. So next thing is the virtual work method na. So considering the structure, so di ba ito yung structure natin, and it has a reaction, pin supported, so AY, AX and AY, which is point A, so C, D. So, balik sa ating problem, di ba, yung deflection natin is at the joint D. So, dito yung deflection natin. So, horizontal or vertical one, we know that deflection is 1 kN. So, mayroong diagonal dito. And this is the deflection. 1 kilonewton. So, the length here is 4 meter. Point B dito. So, length here. From here. 3 meters. So, first thing, same lang previously, mag-take lang tayo ng moment to find the reaction. So, summation of moment at same thing, B is equals to 0, and considering counterclockwise positive, so mag-take tayo ng moment dito, di ba? Anong may reaction dito? Di ba? AY, upward forces, positive, negative, rotating clockwise, so negative AY times 3, negative AY times 3, and then yung deflection natin, which is negative pa rin kasi rotating clockwise 1 times 4. So, wala na. Equal 0. So, AY is equal to transposes divided by 3. 4 divided 3. So, negative 1.33 or in short, 1.33 kilonewton yung nalagay, and then it is facing downward. So, find na natin ang reaction sa summation of forces na natin para makuha natin yung reaction dito sa BY. Summation of forces vertical is equal to 0 and all upward forces positive. So, AY negative, which is facing downward, negative, plus BY natin is equal to 0. Di ba wala ng reaction? So, BY is equals to 1.33 kilonewton and it is facing upward. So, tapos mo dito magiging positive. So, summation of forces na naman tayo, horizontally is equals to 0 and all to the right positive. Kasi meron tayong forces na nag-act dito horizontally. So, meron, considering na ang ating AX have as a reaction. So, AX positive plus 1 is equals to 0. So, AX is equals to 1. So, tatranspose mo yan negative, di ba? So, to the left. Yung direction niya. So, na-find na natin ang reaction ng BY, AY, which is 1.33. BY is 1.33 and AX is equals to 1. So, same thing. Magte-take na naman tayo ng summation forces in all segments para mahanap natin yung mga forces or mga reactions na nag-act every point. So, we're going to use the same method, which is joint method. So, first thing we consider, di ba, yung mga forces or yung may mga maliliit lang na reaction, which is just like B and C, or kasi itong A at saka D merong tigta tatlong reaction. And then, unlike C and D, di ba, dalawa lang. So, first, naanapin natin yung mga forces dito sa may A. Ay, sa may B rather. So, joint B. So, we know that ito yung drawing niya. And this is B, D, and this is A, B. And meron tayong reaction, di ba, dito na 1.33 and it is upward. So, summation of forces na lang tayo. Vertical is equal to 0 and all upward forces is equal to 0. And considering upward forces positive. So, positive, 1.33 plus BD, kasi ito lang yung upward forces, is equal to 0. And then, BD is equal to 1.33 downward, which is negative siya. And then, considering magte-take tayo ng forces horizontally and there is no reaction, so considering that AB is equal to 0 na. So, ilan na yung forces na hanapin natin? AC, CD, tsaka yung AD. So, nahanap natin yung dalawa. So, magte-take tayo ng forces sa joint A na naman. Joint A. Kahit saan lang dito pa. Pero mas depende yan siya kung saan ka mas prefer. So, diba ito yung drawing niya. And then may reaction dito, which is to the left, 1 kN. And this is downward, which is 1.33. And this is AC, which is connected tayo dito, AC. This is AD. And this is AB, which is equals to 0, diba ito? Yung AB natin. So, summation of forces, vertical is equals to 0. Upward forces positive. So, same thing, diba yung length na dito is, rise is 4, and run is 3. And then the diagonal here, so solving natin kanina, which is 5. So, 5. Summation of forces horizontally, ay vertically. So, negative 1.33 plus AC, which is nahanap na natin kanina, wala pa. Hindi pa. And then plus upward forces plus AD, and then rise and then the hypotenuse, which is 4/5. So hindi pa natin nahanap itong AC. So first thing, hanapin muna natin yung AC, which is mahanap natin siya at joint C. So joint C. So ito yung drawing niya. So there is no any reaction sa CD ay sa joint C. So this is AC and CD. So there is no more reaction considering that CD is 0 and AC is equals to 0. So balik tayo dito, 'di ba? AC is 0. So ano na lang, 1.33 negative plus AD 4/5 is equals to 0. So AD times 4/5 equals 1.33. So solving for AD is equal to 1.67 kilonewton and facing upward. So nakuha na natin lahat ng mga reactions sa every segment. So itatabulate na natin for us to easily determine and find the anong problem natin, the deflection, the smallest cross-sectional area at A. So itatabulate natin. So we write here at as member, the length, the forces at the real thrust, and for the virtual and NL, and as their total. So from segment AB, 'di ba, mayroon tayong case first muna AB, AC, AD, ano pa? CD and BD. So ilan lang yung length sa may AD? A to B, 'di ba? 3. A to C upward, so 4. A to D diagonal 5. C to D 3, and then BD, which is 4. Then sa kuha natin yung sa real system, which is this one, at joint AC ay AB. Saan yung AB natin? AB, AC and AD and AB 0. AC natin negative 50 because it is facing downward, and AD natin, AD 166.67 and upward, so positive ito. And then CD natin, CD anong CD natin? 100, which is negative, so negative 100. Ito siya. And then BD, saan yung BD natin? Which is downward, so negative 883.33. And then sa virtual system, sa AB, saan yung AB natin? AB 0. AC 0. Saka CD, 0. And then yung AD natin, AD 1.67 positive, 1.67. Saka yung BD, saan yung BD natin? CD, AB, BD, downward. So, negative 1.33. So, to find the N smaller times NL times the length. So, sa AB, 3 times 0, 0, 0, automatically 0. Any number na times 0 is 0, 0, and 0. So, i-multiply natin ito. 5 times 1 times 166.67 times 1.67 is equivalent to 1.391.95. And then, sa BD natin, ito i-multiply ito lahat. So, we can get 975.32. So, taking the summation of in this area, summation is equals to, i-add dito lahat. So, 2367.27 and kilonewton squared times the meter. So, nakuha na natin yung mga forces sa real tsaka sa virtual. The next thing to do is to find na yung cross-sectional area natin, which is yung A. So, solving that, we're going to use the formula 1 times the displacement is equals to summation of n smaller and larger times the length over the cross-sectional area and the modulus elasticity. So, given sa problem natin, di ba yung modulus elasticity, which is constant, and then I mean 70 gigapascal. So, taking this one, summation is equals to, di ba nakuha na natin yung summation nito? Di ba? 2, 3, 6, 7, ito siya. 0.27 divided by A times 7. Ito yung modulus elasticity natin. 7 times 70 times 10 raised to 6. So, cross multiply. One times times 70 times 10 raised to 6 times A equals to 367.27 kilonewton squared times meter. So, divide natin ito sa 1 times 70 times 10 raised to 6. 70 times 10 raised to 6. So, the answer for the cross-sectional area is equal to 3.338 times 10 raised to negative 3 meters squared. Kasi magka-cancel din ito, Hindi ko na ipapakita. A is equals to gagawin na lang natin itong millimeter. So, times 1,000 magiging 3,381 millimeter squared. And this is our answer for the cross-sectional area. Problem 7.37. So, use the vertical work method to determine the vertical deflection at point B or the frame shown in this figure. So, our structure is has a pin inclined and then as a distributive load, and it is supported by the pin and a ruler. So, let's have its FBD here. So pin supported and may distributed load. So first thing to do is to find the real system. So find the real system for us to easily determine the vertical deflection at point B mamaya, and then next yung virtual system na naman. So first is we're going to find the reaction. So we all know that pin has two reaction, vertical and horizontal, and ruler has one reaction. So this area is 4 meters. I-fill out ko lang muna yung mga detail dito. Is 20 kilonewton per meter, and this is point B, C, A, and may concentrated load na 150. So may distance na 1.5, and dito is 5 meter. So that's it. So na constant yung EI natin, and then yung elasticity, modulus of elasticity is 200 gigapascal, and yung inertia is 500 times 10 raised to 6 millimeter to the fourth. So the first thing to do is to find the reaction, diba? To find the reaction, rather, we're going to find the moment. So summation of moment. At first, mag-take tayo ng moment dito sa A for us to determine yung forces vertically ng C, which is the CY. Summation of moment at A is equals to 0 and all counterclockwise are positive. So mag-take tayo ng moment 150, diba yung trend nito? 150, and it is rotating clockwise, so negative 150 times yung perpendicular distance, which is 1.5, minus 20 concentrated distributive load natin 20, and it is rotating clockwise, so negative siya, and then moment arm is, and then yung moment arm niya is 5.5 times yung total distance niya, total length, which is 5, plus the CY, and the distance is 5 plus 3, which is 8, is equals to 0. So CY, taking CY is equals to, transpose kabila, 150 times 1.5 plus 20 times 5.5 times 5 divided by 8. So total is equals to 96.875 kilonewton, and positive yung result natin, so it is facing upward. So nakuha natin yung forces ng CY natin vertically. So pandali na lang paghanap ng mga the rest na mga forces. So just like AY, so solving for the forces vertical. And all upward forces positive, so AY upward plus yung upward na CY natin, which is 96.875. Ayan, distributive load natin minus 20 times 5 minus 150 is equals to 0. So solving for AY is equals to, transpose lang sa kabila, and then sum up, we can get 153.125 kilonewton and facing upward, because the answer is on the positive. So if we took the forces vertically, diba, we know that there is no any reactions except this AX. So we consider that AX is equals to 0. So 0. So nahanap na natin ang forces vertically or at horizontally ng ating pin support and saka ruler support. So next thing to do here is to find the deflection now at the B. So considering this drawing, this is pin support and this area, and the deflection here, because we all know that it has a distributive concentrated load of 150, and this is the point B there, point B. So, and mayroon tayong reaction dito and reaction dito, which is 0 and 96.85. So, di ba mag-take tayo ng kuan dito ng moment, but then di ba naka-incline siya. So first i-identify natin yung horizontal tsaka yung vertical niya dito, which is AY na vertical tsaka yung AY na horizontal. So di ba meron tayong 153.125. So in solving the horizontal and the vertical, we know that the distance here is 4. Tama? And then dito tsaka dito is 3. So to solve the diagonal here by just using quadratic formula, Pythagorean theorem, we can get 5. So in solving the AY, which is sine, so AY is 153.125 sine, which is 4 over the hypotenuse, which is 5. So it is equal to 122.5 kilonewton. And this is for the AYV natin, vertical. So for the AY horizontal natin is equals to 153.125 times 3 over the horizontal, the hypotenuse, which is 5. So it is equal to 91.875 kilonewton. So na-solve na natin yung reaction ng EY natin, which is the 120 to 91.875. So now we can take the moment here for us to identify. So if we're going to use the cutting section, mag-cut tayo ng area dito, which is just like this. So magiging ganito yung structure natin. So meron tayong ano dito, 91.875, and dito meron tayong 122.5, and this is and if we cut a section here, we can create the positive moment, which is ganyan, and this is counterclockwise. So considering that this area, from this area is we put this as x. So because it is unknown for us, baka kasi nag-cut man tayo ng section dito, so and the total length ng ating diagonal is 5. So hindi natin alam kung ilan yung distance ng ating pinutol. So we just put it as x. So if we take the moment from moment of A, sa A muna tayo, horizontal. So summation of moment at D, deflection, is equals to 0, and counterclockwise positive. So moment, it is rotating counterclockwise, so positive moment, minus 91. Diba hindi tayo magka-create ng moment dito sa 152. So mag-take tayo ng moment dito sa 91.85. So magiging minus 9, 1.875 times the length, which is x, is equals to 0. So there is no other forces. So moment is equals to 91.875 times x. So this is for our AD. And solving for the moment of DB, so same pa rin. So summation of moment B is equals to 0. So moment of DB, positive moment, minus 91.875 x times plus we'll know that it has a concentrated load which is 150. So we take this horizontal and vertical resultant. So we will know that the vertical, if we talk about vertical, diba, 4/5, and the horizontal is 3/5. So we just times the 150 and 4/5 for the vertical, so we can get 90. So 90, so mag-take tayo ng moment sa may B, di ba? Mag-take tayo ng moment sa B, hindi mako-consider yung horizontal, which is 3/5. So hindi natin magagamit yon. So the only thing nga pwede consider is yung 4/5 times 150, which is 90. So 90 times ang arm length, di ba? Ang arm length natin is x. So we all know that the total length of this area is 5. So the half of this is 2.5. So meron tayong x dito. So paano yun? So para makuha yung x is x minus 2.5, and then distribute, wala ng kuan, mga reactions. So moment deflection at D, so equal to distribute na directly, so 1.875x plus 225. So this is our moment at B if we talk about the deflections. So next is the moment at B and C. So dito na part B and C. So if we draw the structure here, diba, distributive load dito, and this is 20. If we cut that section here, B and C, so we know that it has a resultant of 96.875, diba, dito. So if we cut the section here and we consider that this area, so we can create the positive moment, which is clockwise, and then and it has a distributive, and considering that this area is unknown, so we just put it here at x. So we take the moment. So sa measure of moment, mag-take tayo ng moment dito na area. Moment of C D is equals to 0. So may moment, diba, dito kanina, which is yung positive mo, ay considering yung direction ng ating rotation, which is clockwise, ay counter, so positive. So it is rotating clockwise, so negative moment of BC plus yung concentrated load 96.875 x times the arm length, which is x, minus 20 the distributive load times x times the centroid, which is x/2. So moment at BC is equals to distribute, so we can get 96.875 plus 10x raised to 2. So these are the moments that we are going through, diba? Nakuha na natin yung mga moment ng ating moment A, moment AB, and BC. So these are 91.x, then tatlo ito. May deflection man dito. Ito yung deflections. So the problem here is hanapin natin yung deflection at point B. So tapos na tayo sa may real system. So punta na tayo sa virtual system na naman. So we just have the calculation here. So rewriting the structure, and then in this virtual, di ba? If we talk about deflection, considering na meron na yung 1 kilonewton na, and then it is pointing at B, vertical. So 1 kN, and it has a ruler and horizontal, vertical na reaction. C, B, and A. So first thing, just like a previous, we could take the moment to find the reactions, the value breakdown. So summation of moment at i-fill out mo natin yung mga details. This is 3, this is 5, and this is 4. So summation of moment is equal to 0, 0.8 tayo. So negative 1, considering counterclockwise positive, so it is rotating clockwise, so it is negative 1 times the arm length, which is 3, plus our CY, which is rotating counterclockwise, so positive, times arm length, which is 8, is equals to 0. So CY is equals to 3 divided 8, which is 0.375 kilonewton, and it is facing upward because the answer is positive. So summation of forces to find the vertical reaction of A, Y. So summation of forces, vertical is equal to 0, and all upper forces is positive. So upper forces positive, so 0.375 positive, plus AY natin minus 1. So equals 0. So AY is equals to 1 minus 0.75, which is 0.625 kilonewton, and it is upward. So nahanap natin ang forces vertical and sa forces and sa reactions ng ating AX, and we can see that there is no reaction horizontally, so we can conclude that this AX is equals to 0. So same thing, hanapin natin yung deflection dito sa may point B, and considering this area, para manap natin yung moment at A to B. So reaction merong 0.625, and in this area B, and to find this, we're going to find the horizontal and the vertical. So to get that 0.625 times, we all know that this area is 3 and 4, and this area is 5. So we talk about vertical, 4 over 5. So it is equal to 0.375, and 0.625, and vertical it is 3 divided 5, so it is equal to 0.5. So 0.5 ito, and 0.375 yung vertical. So cutting section, so considering this area, so positive moment, which is rotating clockwise, and this length here is so we can put X, summation moment at AB is equals 0, and all counterclockwise positive. So mag-take tayo ng moment is positive moment times the X, and minus rotating upward, so it is rotating counter, so clockwise, so negative 0.375 times the arm length, which is X, so equals 0. So moment AB is equals to 0.375x. So this is our moment at AB. So we're going to find the moment at B tsaka ng D. So considering this area pa rin, so summation of moment at B is equals 0. So there's no more moment pa rin na mangyayari dito sa 0.5. So we just consider that 0.375. So moment of BD is equals to minus 0.375 times x is equals to 0. So moment at BD is equals to negative 375x. So the last thing is yung moment na mangyayari sa my B at saka C. So considering this area and it has a concentrated load of considering this area and the B and C, and there's a reaction which is 0.375, and if we cut the section here, we can create positive moment which is rotating clockwise, and the length here is considering x. So moment at BC is equals to summation of moment equals 0 and counterclockwise positive. So moment BC minus 0.375 and times the arm length which is x is equals to 0. So moment at BC is equals to 0.375. So we're just going to tabulate it for us to easily solve the problem. So we write it has the segment or the member. So segment lang natin lagay, segment, and then yung origin niya. So siya nag-start, din yung limits. Yung moment sa may real system and yung moment sa may virtual system. So segment AB, AD rather, DB, and BC. So origin A, and C. So the limit here 0 to 2.5, then 2.5 to 5, and 0 to 5. So the in real system, our moment at AD is 91.875x, and in DB 1.875x plus 225, and in moment BC it is 96.875 times 10 x squared. So in moment virtual, they are the same. So 0.375x lang. 0.375x, 0.375x, and 0.375x. So the last problem is we're going to solve the deflection at point B. So considering the formula, which is the deflection is equals to the differential of the limits from 0 to limits is equal to the moment real system times the moment of virtual divided by the EI, which is the constant. So these are only the summation. Pwede natin lagay dito summation. So it is equal to 1 over EI times the limits 0 to 2.5 and 91.875x times 0.375x dx plus integral, yung limits niya 2.5 to 5, so 1.875x plus 2 to 5 times 0.375x dx, and plus integral of 0 to 5 96.875x plus 10 x squared times 0.375x dx. Yeah. So in solving this one, so we can get 1923.83 kilonewton squared per meter cube over our EI. So this is our deflection at point B. So considering the problem ay the given, which is the modulus of elasticity and inertia, so we just put it in the equation. So 1923.83 kilonewton squared meter cube divided by 200 GPa gigapascal times 500. So it is equal to 0.0192 meter or 19.22 millimeter, and it is facing downward. Problem 7 to 5. Determine the equation of elasticity curve or elastic curve for the beam using x sub 1 and x sub 2 coordinates. Specify the slope at A and the maximum deflection. So EI is constant. So we can see that this is our structure. So let's have the free body diagram here. So our structure is supported by a pin supported and a ruler. So P. So let's have the details here. Okay. P A, and this is x sub 1 and x sub 2, and the total, this is the length. So this is it for our structure. So to find the answer or to have the solution in this problem, so let's have the cutting section with regards to the two coordinates. So let's have the coordinate x sub 1. So let's have the P stands for the reaction, P, which is vertical. So we know that this is pin support, so it has a horizontal and vertical support. So if we cut the section here, this area, if we cut the section here to find the moments and the shear in this area, in this x sub 1, so we can cut the section, then we can create a positive shear, which is the facing downward, and the rotation of our moment, which is counterclockwise, to have a positive moment. So considering that this area is x sub 1, so P, and in solving the moment, we can get the moment of 1 is equals to x is equals to P times the distance, so x. So moment is equals to moment of x sub 1 is equals to P times the x. So let consider as BA is equal to the vertical reaction, and VB for the vertical reaction at B. So taking the moment, so summation of moment at A is equals to 0 and all counterclockwise positive, so we can get P, which is this one, and it's rotating clockwise, so negative P times this area, which is A. P times A, di ba? P times the perpendicular distance, which is A. So, naging negative P times A. And then, minus this P here, P times its length is, we all know that the total is length, di ba? L, considering L. So, to have the measurement here, we just minus the A to the length, or the total length. So, it's just like L minus A plus the vertical reaction of B times L is equals to 0. So, transpose, so we can get VB is equal to P. So, it's just the reaction of B is equal to the concentrated load. So, for moment x sub 1 is equals to P of x sub 1. So, dito na area. So, the EI times the elasticity curve is equal to the EI times the derivative of x sub 2 V over derivative of x squared. X sub 1 is equal to P of x sub 1. So, EI dV 1 over EX is equal to P this one, and x sub 1 squared divided by plus C1 x sub 1 plus C2 4 is 2. So, you can get that EI times V is equal to P x sub 2 x sub 1 squared, rather, divide 6 plus C I x1 plus C2. So, for boundary condition, we can have the BI is equals to 0 at x is equals to 0. So, EIV is equals to P x sub 2 divide 6 plus CI xi or x sub 1 plus C2. So, if we have that BI is equals to 0, so EI is equals to P 0 squared divided by 6 plus C sub 1 times 0 plus C2. So, we can get C2 or C sub 2 is equal to 0. So, this is the solving if we are focusing at the coordinate of x sub 1. So, next is the x sub 2 coordinate. Start the equation here. So, for x sub 2, so considering the area, the drawing that we have, so this one, this is the x sub 2, so, and we have the P here. So, to have a positive moment, we are facing clockwise. So, this is A here, A, and another reaction dito na P. So, moment 2x is equals to P times A, or the total length. So, gawin lang natin dito yung sa x sub 1 coordinate natin. So, for M2x is equals to PA. So, EI derivative of the x squared v divided by dx squared is equals to p a. So the change in distance over dx. So ei dv sub 2 dx sub 2 is equals to pa x sub plus c3. So this is our equation 3. So ei v2 is equals to p a x sub 2 divide 2 plus c3 x squared plus c4. So the equation 4. So due to symmetry, if we have the symmetry, so dv sub 2 over dx sub 2 is equals to 0. At x sub 2 is equals to the length divided by 2. So ei times 0 is equals to p a times l over 2 plus c3. So 0 is equals to p a l over 2 plus c3. So c3 is equals to p a l over 2. So for the continuity condition, vi is equals to v2 or v sub 1 is equals to v sub 2 at x sub 1 is equals to x sub 2 or equal to a. So solving for that, pa cube divided by 6 plus ca is equals to pa cube divided by 2 minus pa squared l divided by 2 plus c4. So ca minus c4 is equal to p a 3 over 3 minus pa squared l divided by 2. This is our equation 5. So dv 1 or dx sub x sub 1 is equals to dv squared divided by dx sub 2. So at x1 is equals to x sub 2 is equals to a. So p a squared divided by 2 plus c1 is equals to p a squared minus p a l divided by 2. So a, or solving for the c sub 1 is equals to p a squared divided by 2 minus p a l divided by 2. For to substitute, we're going to substitute the equation 5 to the problem here. So dv sub 1 dx sub 1 is equals to p times x sub 2 1 plus a squared minus a times l divided by 2 times the ei. So the change in slope of a is equal to the dv1 divided by dx. Absolute value of x sub 1 is equals to 0 is equals to pa times a minus l times 2 ei, and so solving for the vi is equals to p times x sub 1 squared plus 3a times a minus l divided by 6 ei. So this is for the v sub 1. So for the v sub 2 it is equal to pa 3x times x minus the length plus a squared divided by 6 times the ai, and this is for the v sub 2. For the v max, for the shear max, so v squared is divided by x is equal to l divided by 2. So it is equal to pa times 4a squared minus 3l squared divided by 24 ei. So this is the solution. Problem 8 to 9. So use method of virtual work and determine the vertical displacement of point A. So use each steel member has a cross-sectional area of 400 mm squared. E is equals to 200 gigapascal. So this is our structure, and it is supported by the two pin support. So let's just draw its FBD here. So just like this. So fixed support, pin support rather, support, and it has a back, and this one, so that's a 20 kN. So I'll just put here all the information. One point five, and so 2 meters. So first thing, just put our equation here. So the first thing to do is to determine the reaction. So we all know that this is a pin supported, so it has two reactions, which is horizontal and a vertical reaction for both. So we just find the forces in every joint for us to determine the possible reactions every segments. So first, let us have the joint A. At joint A. So as you can see, this is it's drawing, and it has a 30 kN, and this is connected to B, which is put as AB and AE. So for us to determine, we all know that the inclined plane has a run of 1.5 and 2 as its rise. So summation of forces, vertical is equals to 0 and all upward forces positive. So 30 downward, so minus 30 plus upward forces ng AE plus AE times upward vertical, so sine 2 over square root of 2 squared plus 1.5 squared, so is equal to 0. So AE is equal to transpose, then divided by, so we can get 37.5 kilonewton upward forces, because the answer is positive. So solving for the summation forces horizontal is equal to 0 and all to the right are positive. So we can see AB and plus the AE, which is 37.5, because we just solved the AE. So the horizontal for AE is 1.5 over square root of 2 squared plus 1.5 squared is equals to 0. So AB is equal to negative 22.5 kilonewton, or 22.5 downward. It is horizontal, so it is to the left. To the left yung kanyang direction. So next at joint B. So ang nangyayari ngayon is we are using the real system. Then ganito yung sa B. Concentrated load na 20, and this is for AB, and this is for BE and BC. So summation of forces, vertical equals 0, and all upward forces positive. So we can see BE is upward, so positive. BE minus 20, so 0. So BE is equals to 20 kilonewton upward. So upward yung BE natin. So next, horizontal na naman tayo. Summation of forces, horizontal is equals to 0, and to the right is positive. So nakuha natin yung AB, which is 22 to the left, so negative 22.5 plus yung BC natin is equals to 0. So BC is equals to 22.5 kilonewton to the right, kasi positive. So next thing is joint EE na tayo. So nasolve na natin ang AB, BE, BC, and AE. So konti na lang yung hahanapin natin na mga reactions. So at joint E na tayo. So we all know that this is its drawing. So BE, AE, and CE, and DE. So summation of forces vertical is equals to 0. So we all know that AE is 37.5, and the vertical is, what is the vertical? 2 over square root of 2 squared plus 1.5 squared minus with BE, which is 20, so upward, so minus 20 minus yung AC natin, which is ilan yung sign nya, which is 2 over square root of 2 squared plus 1.5 squared equals to 0 kasi wala nang mga forces. So AC, so for AC, it is equal to 62.5 kilonewton, and it is facing downward. So summation of forces na naman tayo, horizontal is equal to 0, and all to the right positive. So negative 3.7 yung horizontal ng EE natin times 1.5 over square root of 2 squared plus 1.5 squared plus yung AC natin, which is negative 22, negative 62.5 rather, times its sine or vertical. So 1.5 over square root of 2 squared plus 1.5 squared plus yung ED natin. So ito yung last is equal to 0. So ED is equal to 60 kilonewton at is horizontal, so to the right, which is positive. So these are all our reactions in all segments using real system. So now let's move to the virtual system na. So virtual system, and baka ganito the problem, which is it is said that the vertical displacement is at the point A. So let's have the drawing. So ng virtual, this is pin supported, and 1 kilonewton. So this is our drawing for virtual. So joint A. So summation of forces vertical 0. So vertical A, E, diba, D, B, and C. So summation of forces vertical, we are focusing on point joint A. So the drawing is just like this. Then may 1 kN. So 1 kilonewton forces vertical. This is AE rather. So this is AE and AB. So AE 2 over square root of 2 squared plus 1.5 squared minus 1 is equals to 0. So AE is equals to transpose and divided by, so we can get 1.25 kilonewton upward because it is positive. So solving for the vertical, summation of forces vertical is equals to 0 and also that positive. So we can say that our AB is positive, then plus our AE which is 1.25 times the cosine which is 1.5 over square root of 2 squared plus 1.5 squared equals 0. So we can get 0.75 to the left kilonewton. So this is for our joint A. So let's move for the joint B. So at joint B, so we can see that this is like its drawing. So this is BE, BC, and AB. So summation of forces vertical is equal to 0 and all upward forces positive. So considering the AB is 0.75 and so summation of forces, so we can see that BE is only the forces vertical, so we can conclude that BE is equals to 0. So summation of forces horizontal is equals to 0, to the left is positive. So we all know that our BC is negative, so negative of 0.75 plus BC is equal to 0. So BC is equal to 0.75 kilonewton to the left. So that's it for our B, joint B. So next, for us to determine the remaining, so we need to find the forces at joint E. Joint E, so ganito yung drawing. This is BE, AE, CE, and DE. So summation of forces vertical is equals to 0. So we all know that AE is 1.5. So 1.25 rather times its vertical, which is 2 over square root of 2 squared plus 1.5 squared times plus the BE, which is, we can see our previous solving that BE is equals to 0, and our CE vertical plus CE we consider tension, so we can say that this is negative, so because it is facing downward, so negative CE times the vertical, which is 2 over square root of 2 squared plus 1.5 squared, so it's equals to 0, so there is no more. So C is equals to transpose and divided by, we can get 1.25 25 kilonewton and facing downward. And for our horizontal, summation of forces horizontal is equals to 0 and all upward force is positive. So I mean to the right positive. So we can see our EE has horizontal, which is negative 1.25 times 1.5 square root of 2 squared plus 1.5 squared, and plus the AD or the DE and our CE, which is 1.5 facing downwards, minus 1.25 times 1.5 over square root of 2 plus 1.5 squared equals 0. So DE is equals to 1.75 plus 0.75, so we can get 1.5 kilonewton to the right. So these are all reactions that we have in every segment. So for us to easily determine the finding problem, which is the vertical displacement, so we just put it in a table for us to easily solve for the problem. So we just put it as a member, the length, the forces in a real system, the forces in a virtual system, and their total. So member AB, we have member AB, we have AC, a BC rather, BC, we have AE, BE, CE, and ED or DE. So the length from AE, AB to AE, A to B, which is 1.5, B to C, same, 1.5, A to AE, which is square root ng squared, which is 2.5, BE to CE 2.5, and ED is 1.5. So back for our previous solving, which is our virtual, real. So we can we have solved that AB is 22.5, which is negative 22.5, and our BC is also 22.5 and it's facing to the left, so negative 22.5. AE is 62.5, ay 37.5 rather, 37.5, and this is positive because it is facing upward. And BE, which is 20 and upward, positive. CE, where is our CE? CE is 62.5, negative, and our ED is 60, so it's positive. So these are our reactions at real system. So in our virtual, our AB is 0.75, so negative 0.75. Our BC is negative 0.75 also. Our AE where's our AE? Upward 1.25, which is positive. Our BE is 0. Our CE is negative 1.25. Our ED is positive 1.5. So summing up, taking their total, which is they just multiply each other. So 25 times 1.5 times 22 times positive, so negative times negative, so positive, times ng 1.5, so positive 25.3125. Next, BC, multiply mo lang, so we can get 25.3125, same lang because they have the same numbers. Then 117.1875, then 0, so 2.5 times negative 62.5, so we can get 195.3125. And the last 60 times 1.5 times 1.5, we can get 135. So summing up, so we can get 498.125 kilonewton squared per meter. So this is our total forces in our structure. So in solving the deflection or the vertical displacement, we're going to use 1 times the displacement summation of n smaller times n bigger times L divided by AE, which is given, so it is equal to 498.125 kilonewton squared times meter divided by the given EE, which is 400. We're going to convert it into meter, so 400 times 10 raised to 6 meter squared for us to have cancellation. Our A, or which is 200 times 10 raised to 6 kilonewton times meter squared, your gigapascal. So solving for it, we can get 6.23 times 10 raised to negative 3 meter, or 6.23 millimeter, and it is facing downward. So this is our change or a vertical displacement and in this problem. Problem 8 to 59. So determine the slope at A and a vertical displacement at B. So use the method of vertical work. EE is a constant. So as you can see, our structure is supported by a ruler and a hinge. Pin supported. So let's have it fitted by the diagram. So first, let's have the rail system. So it is supported by a ruler and pin. So that's a 60 distance here, and here is 4 meters. So let's have the details. And 3 meters. So we all know that pin support has a two reactions, which is the vertical and the horizontal, and the ruler has the one reaction. So let's label it as A and B. So for us to determine the reactions, we just find the summation of moment. Is equals to 0. So let's have the moment at point A. So A. counterclockwise are positive. So let's have the 60 here, which is there 60, and it's rotating clockwise, so negative 60 times the arm length, which is 4, minus the bx, the vertical, and it's rotating counterclockwise, so it is positive, plus bx times the perpendicular distance, which is 8, equals to 0. So bx transposed and divided by 8, so we can get 30 kilonewton, and it is positive, so the direction that we had is correct, so it is to the left. And summation of forces vertical, first to determine the ay, horizontal is equal to 0, and all to the right positive. So let's have the negative 30 plus 60 plus ax is equals to 0. So ax is equals to transpose minus 30, so 30 kn to the left also. So our reactions are 30 to the left for bx and 30 for the by. And so on summation forces vertical equals 0, upper force is positive, so we know that there is no reactions that happening at or existing at vertical, so we can conclude that ay is equals to 0. So let's have here the moment in its segment. So let's start in segment or member AC. So we just labeled at this part as AC or C. So summation of moment at AC is equals to 0, and counterclockwise is positive. So we can see that if we take the moment here, so we just label this as x, so moment, and it's rotating. And if we have the moment which is there, which is rotating counterclockwise, so it is positive. So moment AC, which is positive, minus the reaction, horizontal reaction, which is 30. So 30 and the perpendicular distance, which is x, so equals to 0. So moment AC is equals to 30x. So segment BC, so in this area, so we know that there is a reaction horizontal, and if we cut the section here, we can create a clockwise rotation. So summation of force moment at BC is equals to 0, and counterclockwise is positive. So moment BC positive minus 60, which is this one, 60 x times 4 x over 5, the perpendicular distance, minus 30 times 40 plus x times 4 over 5 times x is equals to 0. So summing up, moment at BC is equals to negative 24x squared plus 120. So these are the moments and the reactions in real system. So let's have the solving for our virtual system. So first, let's have considered that our vertical displacement is at B. So this is our structure. So it's supported by a ruler. So there is a displacement. So we know that it has a reaction, horizontal, vertical, and also there. So summation of moment, so we just label it as A and B. So summation of moment at A is equals to 0, counterclockwise positive. So mag-take tayo ng moment dito. So we know that this is rotating Bx. So Bx is Bx times the distance, vertical distance, it's 8 minus 1 times 3 is equals to 0. So Bx is equals to transpose and divide, so we can get 3/8 kilo Newton, and it's facing to the left, so negative. So summation of forces vertical is equals to 0, and all upward forces positive. So AY, which is there, AY plus 1 kN or 1 kilonewton is equals to 0. So AY is equals to 1 kilonewton downward. So, and summation of forces horizontal is equals to 0, and all to the right positive. So AX minus ano yung BX natin, di ba, 3/8. So 3/8, which is facing to the left, so minus equals 0. So transpose X equals to 3/8 to the right, kilonewton. So to get the moment, so segment AC tayo. From here to here, mag-take tayo ng moment dyan. So summation of moment at AC equals 0, ano, counterclockwise positive. So mag-take tayo ng moment dito, di ba 3/8 ito, and our AC is AX is 3/8, so it is rotating. So considering that this area is X, so moment AC positive minus, it is rotating clockwise, so negative, so 3/8 times X is equals to 0. So moment at AC is equals to 3/8 X. So from segment BC, this area, so summation of moment at BC is equals to 0, and all counterclockwise positive. So mag-take tayo ng moment dito. So considering this is area, so it is rotating counterclockwise, so positive. Moment BC minus the forces, which is 3/8, and the distance is 9 plus 4x/5 times plus x times the perpendicular distance of this x, this area, and this Newton, this is x, 1 kilonewton times the perpendicular distance, which is 3/5x equals to 0. So moment BC transpose, so we can get negative 0.3x squared plus 1.5. So this is the moment for, so another virtual for, so considering that our displacement is at A, so it's just like this ruler. So this is our 1 kN, so A, and then C and B. So to get the reaction, and this is a AY and AX, and this 1 kN per meter is our moment, which is rotating counterclockwise, so positive. So summation of moment at A is equals to 0. So B, and the distance is 8. B horizontal times 8 minus 1 is equals to 0. So Bx is equals to 1 over 8 Kn. And then summation of moment at B is equals to 0. Considering counterclockwise, positive. So if you take the moment here, so 1, which is rotating clockwise, so negative 1 plus 1 over 8, our Bx 1 over 8 times perpendicular distance, which is 3 plus 2, 5 minus AY times 3 is equals to 0. So AY is equals to, solving this one, so we can get a 0 answer. So summation of forces, vertical is equals to 0 on all upward forces, positive. So 1 over 8, our AY 1 over 8 plus AX is equals to 0. So AX is equals to 1 over 8 kilonewton. And for segment, so we're going to solve the moments at AC. So if you take the moment here, so we cut this area, and this is X. So we have the positive moment. So moment is summation of moment at AC is equals to 0 and all counterclockwise positive. So moment AC is equals to minus, take the moment here, there is a negative, rotating counterclockwise, so clockwise, so negative 1/8 times the perpendicular distance, which is 8, minus the Newton, which is clockwise, minus 1 is equals to 0. So moment AC is equals to 1 over 8 X plus 1. So for segment BC, so summation of moment at BC is equals to 0 and all counterclockwise positive. So moment BC, the moment here, we can get a positive moment, and then MBC or moment BC minus 1 times minus 1 over 18 times the distance perpendicular distance, which is 4 plus X times 4X divided by 5 is equal to 0. So moment BC is equal to 0.1 X squared plus 0.5. So these are all the moments that we're going to solve for the vertical displacement of A, determine the slope of A and the vertical displacement of B. So solving for that, so solving for the displacement of B, so displacement of B is equals to, we all know that the formula is 1 over EI, and summation of integral of moment of real times the moment of virtual dx. So it is equal to 1 over EI integral of 30x. So, the first thing is our virtual, diba 30? Yung sabihin natin, diba 30x? Bix natin, 30x times segment BC, which is 3x over 8 times 3 over 8x dx plus, and the limits is 0 to 4, which is 0 to 4, and then integral of 0 to 5. This is negative 24. This one for moment BC, negative 24 x squared plus 120 times the virtual, which is negative 0.3 x squared, negative 0.3 x squared plus 1.5 dx plus integral of, that's all, equal to 0. So we can get, taking all the antiderivative, so we can get the change of displacement of B is equal to 540 kilonewton times meter cube over our EI, which is the constant. So in solving, the slope of A is equal to 1 over EI, summation of 0 to length, from 0 to the length, moment of virtual times moment of real dx. So it is equal to 1 over EI. It is 30 integral from 0 to 4, 30x times 1 over 8x plus 1 dx plus integral of 0 to 5, 0 to 0, negative negative 0, this one 0.3 x squared plus 1.5 times 0.1 x squared plus 0.5 dx. So solving that, we can get 260 kilonewton per meter squared over EI. So this is our slope of A and the displacement at B.